Hello students, welcome to Simplify, where we turn your moments into aha moments. I am Kirtan Kumar B. So in this series, I'll try to solve some problems of refraction. Now, I guess let's not waste time and let's just dive into the problem now. This is problem number 1. A light ray enters through a right angle prism at point P with angle of incidence 30 degree as shown in the figure. It travels through the prism parallel to its base BC and emerges along the face AC. The refractive index of the prism is a quite intriguing problem actually. So let's see. So if we see, this is our incident light ray, so I can consider this to be my angle of incidence I1, and correspondingly I can choose this one to be my first angle of R1. This dotted line here represents the normal which we have drawn at the point of incidence perpendicular to the refracting surface. So here it is at point P. Now you see that after refraction through the prism, the light ray is traversing on the surface of AC. So the angle of refraction here is 90 degree. So if I choose this one to be angle of emergence E, the angle value comes out to be 90 degree. And let me choose the angle within the prism to be angle of refraction R2. Now we have another relationship which we can use here, that is angle of a prism A equal to angle of refractions, the sum of angle of refractions R1 plus R2. So the question says it is a right angle prism, and in the figure also they have mentioned that it is 90 degree. So this angle I can take it to be 90 degree. Let's just keep this as point number 1 or equation number 1. Now if we see the prism some problem, so we think of like solving this using a simple equation that we have, that is refractive index of the prism. If I represent it is equal to, it's the ratio of sine of angle of prism plus minimum deviation divided by 2 and sine A divided by 2. Now for this problem, this equation can't be used because as I just mentioned, this D represents the minimum deviation value. Now for minimum deviation case, the value of I1, the angle of incidence and the angle of emergence, I1 and I2, angle I1 and I2 should be a constant, and also mainly I1 should be equal to I2, if I can simply say that. I1 should be equal to I2. But in our problem, if we see, the incident angle and the emergent angle, both of them are not equal. So quite sure that we can't use this equation. So how to approach this equation? Let's use the basic stuff. The second law of refraction, that is Snell's law. Now Snell's law states that the sine of angle of the ratio of sine of angle of incidence to sine of angle of refraction gives a dimensionless quantity. So that quantity is called as refractive index, which helps us to understand the velocity or the behavior of light within a certain medium. Now Snell's law is given by refractive index equal to sin I by sin R, which gives me a relative refractive index between two mediums. Now let us apply Snell's law for the first surface AB. Applying Snell's law for the first surface AB, we have refractive index of the prism. Let me represent the refractive index of the prism be NP. This is equal to sine of angle of incidence is I1 for the first surface, and angle of refraction is sine R1. Now the value of sine I1, we do know that from the given question it is sine 30 divided by, now here sine R1, I don't know the value, let me just keep that as it is. Now I do know the value of the sine 30, it is 1 by 2 or as half. Now then this equation turns out to be 1 divided by 2 sine R1. So let me just keep this as equation number. So I've already taken it as 1, so let me just keep this as 2. Now I can't move any further, but if you see the question clearly, we have another surface AC where we have another data, the I value, the E value, the angle of incidence here is emergence. So let's just apply the Snell's law for the surface AC part. So then the refractive index of the prism comes out to be, and notice that the refractive index of the prism is not changing because the material of the prism is not at all changed. It's the same prism. Now it is sine E divided by sine R2. Here it is the relative refractive index of the prism, where we are incidenting the light ray from the rarer to denser. Then we will get the refractive index of the prism with respect to the outside medium. So you guys have to be careful that it is not sine R2 by sine E, it is sine E by R2. Now we do know the value of sine E, it is sine 90 in this question, divided by sine R2. Now here also we do know the value of sine 90 from trigonometric ratios. It's a standard angle. So the value comes out to be 1. So the answer is 1 divided by sine R2. And I can take this as equation number 3. And notice that if I just find the value of sine R2, I have the answer NP. Or if I just find the value of R1, I have the value of NP. If you note, so let's move on to find that value then. So if you notice, the LHS part of the equation 2 and equation 3, both of them are same. So I can equate both of them. So equating 2 and 3 because LHS is same. Now what do I have then? Now I have 1 divided by 2 sine R1 equal to 1 divided by sine R2. Now I can take this R1 to the RHS part, so that is sine R1 divided by sine R2 equal to 1 divided by 2. I just took this out to the right hand side part. Now if you remember, in the question we had R1 plus R2 equal to 90 degree. Now I can use here. How? If you notice, R1 plus R2 equal to 90 degree, so then I can represent R1 value as 90 minus R2, right? So I can replace the value of R1 here as 90 minus R2. Why? You will see why. Now this is sine, R1 value comes out to be, I just replaced it by 90 minus R2 divided by sine R2. This is equal to 1 divided by 2. And we do know from the first quadrant, sine 90 minus theta is cos theta. So this is sine 90 minus R2 comes out to be cos R2. So this value I can just simply write it as cos R2 divided by sine R2. Now what is sine? Cos by sine? Sine by cos would be tan. Now cos by sine would be cot. So this is cot R2 equal to 1 divided by 2. Now if I just take up like a triangle, especially a right angle triangle, because trigonometric functions are only applicable for right angle triangle. This is a right angle triangle, and let me choose this value to be R2. I can give some letters, it's not necessary. For this R2, this is the opposite side, this is the adjacent side, and this one is the hypotenuse side. Now cot is nothing but, if I represent cot, R2 is nothing but it is adjacent by opposite side. Now adjacent side value is 1, adjacent side value is 1, and opposite side value is 2. So this is 2. Then hypotenuse value comes out to be, from Pythagoras theorem, it is 2 square plus 1. So this is how much? 2 square is 4 plus 1 is root 5. Now what were we expecting? As I just said, we just wanted the value of this sine R2 and the problem was already solved. So the refractive index of the prism equal to 1 by sine R2. So let's just find the value of R2. So here R2, sine R2 comes out to be, sine R2 is opposite by hypotenuse side. Opposite side is 2. Hypotenuse side is root 5. Now comparing this with the above equation out here. So if I see this equation with this equation, now I can just compare them. That is, refractive index of the prism is 1 by sine R2, and I got sine R2 value to be 2 by root 5. Now I can take this to the numerator part. Denominator of the denominator goes to the numerator part. So this is root 5. I am taking this to the numerator part. So this is root 5 divided by 2. The refractive index of the prism comes out to be root 5 divided by 2. So the answer for this question is option B, root 5 divided by 2. So thank you so much. So if this helped you simplify even one concept, tap that like button. It really supports the effort. Subscribe for more, and we have new videos up every week. Join our awesome learning community in Discord and also follow us on Instagram. You can find the links in the description. Thank you so much. Thank you for joining.